We stand on the threshold of a great new age of exploration. Its ultimate destination, the furthest reaches of the universe.
3, 2, 1.
Good evening, everybody. How are we doing out there? Yes. Welcome to the Frontier here on the campus of the beautiful Research Triangle Park for RTP180 AI and Automation. I am your host, Andrea Cash, and y'all, I'm real. I'm not AI. You got a live host for now, so enjoy it. These are the good old days, right? These are the good old days. I own Andrea Cash Creative in Durham. I help local small businesses and nonprofits with their communications. I am happy, as always, to be your host. On behalf of the RTP 180 team, we want to thank RTI International. They are our presenting sponsor. Give it up. Yeah. And a big thanks to contributing sponsor, District Station, a Zaremba management company. In keeping with tonight's topic, you might have noticed we had an AI photo booth in the lobby for you to play with. We also had a demo from Single Store. Single Store is a San Francisco-based software maker. They chose Raleigh for their East Coast expansion in 2021. They use AI in cloud database management software. So we were happy to have them. Thank you. Let me remind you about the format. We've got 4 speakers tonight. They're going to talk for about 7 minutes. We really try to stick to that time limit so that there's time after each speaker's presentation for some Q&A with the audience. For the audience Q&A, you raise your hand if you have a question. I'll run around with the mic. So be thinking of your questions as our speakers present. Feel free to engage on social media. The hashtag is up there, RTP180, and you can tag us at FrontierRTP. A bit about our lovely venue. The Frontier has been a home for creative freelancers, startups, STEM professionals, and emerging companies since all the way back in 2015. In addition to everyday co-working, the Frontier hosts special events. We're talking out-of-office happy hours, yoga, tons of pop-up events. I encourage you to check out the full calendar. RTP.org has the full calendar. With that, we're going to get to our first speaker. She is an award-winning writer, researcher, educator who has dedicated her career to making mathematical modeling and data science more accessible to all. She is the inaugural executive director of the NC State Data Science Academy, and she's a professor of mathematics. Let's welcome Dr. Rachel Levy. Step over here if you want it.
Thank you. Hi, everybody. Once upon a time, I was driving on a dark country road. I had 2 kids in the back. And as I was driving, a baby deer came flying out of the woods to my right to cross my path. In these moments, time kind of stands a little bit still, and you have a minute to think, what do I do? And so I thought, what do I do? Should I hit the deer? Maybe that's what driver's ed said to do. So I looked to my right, and there was a grassy shoulder. And I thought to myself, well, maybe if I time it just right, the deer can cross the road, I can go just a little bit off in the shoulder, and everybody will be okay. I thought, that doesn't seem like a very good idea. And then I looked to my left, maybe I can just go to the left, but there was an oncoming car. The headlights were coming towards me, and I didn't know what to do. This is what I think about when I think about self-driving cars. Right? I think about the situations in which there are decisions to be made. Who do we save? Right? Who do we hurt? Who do we not hurt? And I think about, well, what happens if that deer is the bicycle? Right? What would have happened if that deer was a child? What would I have done? I had 2 kids in the back. Then I think about, okay, well, what if I had a fully self-driving car? And then the other car is also a self-driving car. And our cars are made by different companies. Right? And so the algorithms might have different ideas. Have you ever been in a hallway where you're dodging, trying to dodge somebody, and you both go the same direction? You end up colliding anyway? It's possible if the self-driving cars are not coordinated in their actions. These are the things I think about. I was in Phoenix the day a woman took her bike across a dark road and was killed in Tempe. So I think about these things. And it's my job to think about these things now as I help people build AI for research, for education, for agricultural extension, for all of North Carolina and beyond. And so I think about, what if it had been a child and I'd hit them? What would happen next? I would go to court and I would say, here's what I was thinking. Here's why I did what I did. This is why it was the best I could possibly do in the situation, in the time I had. This is what I did. And I'd have to explain myself. And then a decision would be made as to my responsibility. If it's 2 self-driving cars, how does that process work? And how do we as builders of AI make sure that the things we do are explainable so that proper responsibility can be assigned in the situations where there are real decisions? Somebody's going to die. Who dies? This is a very old ethical problem. People have discussed it for centuries. But it's also a real problem, and our laws, our policies aren't quite set up yet to deal with this. If we are going to have policies and laws and enforcement to deal with it, we still need that explainability. Right? We still need to be able to say, why did the thing happen? Why did it happen? You know, with AI and automation, and I'm super excited about it in lots of spaces, in research and education and beyond, as long as everything's going great, we sometimes don't care why it works. We're just like, we got a better solution than the humans could get doing it this way, and we'll take it. It's good, right? Let's use it. And as long as everything's working great, it's great. It's when things don't go great that you need that responsibility, that explainability, right? And so we do need to think ahead and prepare for that. All right, so back to the road. On the road, I was holding the steering wheel, kids in the back, deer coming across, oncoming car coming for me. And I thought, okay, just hit the deer. So I held the steering wheel a little tighter. I think I even slightly accelerated because my brain told me that the timing would be better. I hit the baby deer. The deer went spinning. I looked for it the next morning. It wasn't there. I have no idea what happened to it. The oncoming car missed it, came by, and everything seemed fine. But at that moment, my headlights also shone on 2 hikers coming towards me on the grassy shoulder. If I had taken the grassy shoulder, I absolutely would have hit them. So I think AI might have been able to show me that those hikers were there, because I could not see them, right, when the headlights were hitting my eyes in a certain kind of way. I'm really excited about the technology we're building on the way to automation that helps humans function better, this human-machine teaming that we will see and we already see in our present and in our future. The thing I want you to remember is, as we build AI, every decision behind what happens and that responsibility is made by a human. We decide what data to use to train our AI. We decide what weights to put in it to bias in the best of the meanings of that word, that solution to do the thing we want it to do. We do it. We make those decisions. Behind every AI, there are many, many human decisions. That's a good thing. What we need is to be able to remember to make things transparent and explainable. Thank you very much.
Thank you, Dr. Levy. Questions for Dr. Levy? We'll go right here.
Hi. So thinking about your story, I was wondering if you can speak a little bit about your social credit in that sense, and whether or not AI, in that sense, like let's say the hikers had a lower social credit than the child walking across the street was. Have you thought about that aspect and how that would play a role?
Yeah, so the question was, I think, tell me if this is right, when you make a decision about who to save, you have to somehow decide based on what might be called social credit, or some sort of decision-making process. There have been really interesting studies done with people all over the world about how they would make this decision, right? Between a child, an elderly person, a disabled person, a person. Let's see, different kinds of animals. You can look up the studies. It's super interesting. What's interesting to me is that this varies by culture. It's not uniform, even on average, from country to country or parts of the world, how we preference things. So again, the AI that's developed in one part of the world might have a different social credit or way of preferencing one person over another. It may be that you don't hit this type of animal no matter what. Right? You preference that over the humans, right? Or you never preference an older person over a younger person. In other places, there's laws that say you can't do that. You cannot preference a younger person or an older person. You have to treat them equally. And so the ethicists amongst us are really valuable resources in that they've been thinking about these problems for centuries, and at least they understand the conundrums that we face in assigning that social credit. Thank you very much for your question.
Go over here.
Thank you. Would you mind sharing just briefly what your academy does and then how that relates to the training or interactions with AI?
I would love to. Thank you so much. So the Data Science Academy is 3 years old. I came to NC State to create it. It sits in the Office of University Interdisciplinary Programs in the Provost Office, and we have a mission to network and enhance data science across all the points of the mission. So research, engagement, extension, like I said. So we do a few things. I can't say them all, but I'll try to say it as quickly as possible. So we have about 20 one-credit classes every semester that are all project-based. And you're all going to want to take them because we have a rule: no quizzes, no tests. Signing up, right? Come take our classes. The public can sign up. We also do customized training for industry, where we call that data or AI at work. We train you with your data, doing your tasks, again, with that project-based approach. So we can do that for you, data at work. We did it recently with extension agents. We've done it for companies in the park. We've done it for our sponsor tonight, RTI. We've done it for the Department of Health and Human Services. So we serve North Carolina by giving these same kinds of upskilling. We also give seed grants to enhance interdisciplinary research, and we advise on a new whole floor of a building that's gonna have, you could call it co-piloted labs or self-driving labs. So we're advising that new research initiatives, as well as connecting researchers around campus with each other. And we're super interested in something we call BYOD, for grad students, bring your own data, where we train grad students in modules where they have sort of an algorithm in common, or a tool they want to learn how to use, but they bring the data from the research they're going to do as a grad student, and together they learn how to use this algorithm, trying different kinds of data. So they not only learn it on their own data, like data at work, AI at work, but they also can see how it worked on other people's data. So those are the kinds of things that we're standing up. There's a lot more. We do a lot in the K-12 space. We recently worked with the Department of Public Instruction on a new career and technical education data science class as well. So super excited about all the people in all the spaces. Come see me if you need anything. We have it for you at NC State.
I saw a question back here.
Thank you for taking my question. What is your opinion on Tesla full self-driving?
Can you say that one more time? I'm sorry.
So what is your opinion on Tesla full self-driving?
What is my opinion on something for self-driving? What's Oh, I'm not going to talk about a particular company here. Nope, next.
Question over here.
I mean, I'll say the same thing about any company. I mean, the messages I gave, right? The messages are the same. It doesn't matter the company, right? We have to really think about when the things go wrong, how do we understand what happened? And then how do we appropriately assign responsibility? That's really for any company.
Thank you. So you said that the students bring their own data and you train them on that?
Yes.
Sort of like machine learning for humans?
Yes, exactly. Or companies. We do it with companies as well.
So the question is, if they bring their own data, does that data have to be scrubbed for data quality before it's used for AI work?
Yeah, so the question is, if our learners bring their own data, does it have to go through the usual processes that we know take most of the time in data projects of, looking at the quality of the data, the provenance of the data, where it came from, the cleaning of the data, were there missing values, were there errors in the data, does it matter, all of that, absolutely. So that's going to be part of any workflow, and then in these classes we're going to decide, is this part of the workflow or something we step them through beforehand, and then maybe they're ready, they come. It depends on the timing in the class, because again, that can be the most lengthy part of a data pipeline, is that cleaning process. Absolutely.
We're going to go over here, include this part of the room.
Hi. And thank you for sharing your story. And going back to that story, I'm very empiric on all these things related to statistics, AI. I'm passionate about it, but I'm a linguist. Still, I had this question. Knowing that AI is data, and knowing that that's the immediate goal that's happening and that's going to happen in the future, is the collection of all data have it in our hands. What do you think, or how long do you think it's going to take for your car to know in advance that that deer is in the area, that the people, the people with the bikes are coming, and that scenario is happening there? I'm thinking about cameras, security cameras, all that information happening in just one place.
Yeah, I think, so the question was like, how long till we have perfect information? I think the issue is even if we had perfect information, you will still have these ethical conundrums. So you will have perfect information in which you perfectly know that someone's going to die, could be this one or that one, and the actions that you take will almost certainly cause that problem. And there may be no way out. Like, there's going to be some situations where there isn't a good solution. There's just going to be a choice between terrible solutions. Those are the problems. I mean, if there's easy solutions, right, with perfect or imperfect information, if there's easy solutions, we just take it. The things I'm concerned about, in addition to the reliability of in the good situations, is, and what do we do in those terrible situations? In terms of a timeline, I do, know people in the car automation industry. We have cars on the roads that are fairly automated, and at the same time, it is viewed as a very hard problem that we are very far from solving as well as we would like. So it's both, but we're in it, and if we're going to stay in it, we need to be able to understand what's happening and explain it. So does that catch what you were asking? Yeah, okay. And thank you for being here as a linguist. I'm excited that you're here.
One last question.
Thank you, and thank you for your story as well. Similar to like a trolley cart scenario,
Exactly.
Trying to decide who dies, who takes punishment, you really touched on the importance of ethics and the intentional decision-making that goes behind that.
Right.
You also touched on maybe cultural differences and differences of ethics. Are we duty-driven? Are we in-goals-driven? And I'm curious, with the work you've done, do you have any advice or tips for how to navigate the ethics and the decision-making that goes behind these decisions when different people have very different ideas of what should be happening and can back it up with decision-driven ethics?
Yeah, I don't know if I have good tips, but I have a disciplinary answer. I'm a mathematical modeler. If I want to understand things, whether it's a situation where I need to make a decision or I want to understand a person I really disagree with, I always start with, what's your goal? What's your objective? What are you trying to achieve here? We can almost automatically understand our differences if we understand that we really do have different goals. A lot of times, we might have the same goal, but different assumptions. So the next thing I go to is, what do you think the constraints are in this situation? What are your assumptions? And again, sometimes you can really understand what's going on or what to do based on what you choose to assume or what you already assume. And so surfacing, this is what we're trying to do. This is our goal. We're trying to maximize this, minimize this, make it faster, make it cheaper, make it better, hurt fewer people, make the hurt everybody, but hurt them a lot less, right? Whatever it is, just those are your goals. And then what are your assumptions about that? Children are more important than adults. Adults are more important than children. Animals are more important than people. People are more important than animals. Just say it, right? Just say it. And then use those things to build your decision-making, whether it's a human decision-making or a machine decision-making, to be able to explain, this is why I took the path I took. Or this is where we agree, and this is why we disagree. It's really useful. So be mathematical modelers. Start with, what are you trying to achieve here? And then, you can always ask a question. Do you assume this? Do you assume animals are more important than humans? It can just help you have a conversation. Whether you agree or disagree, you can surface those assumptions and build bridges. And I really encourage you to talk with people you don't agree with.
It's good to end on. Thank you, Dr. Levy. All right, great questions, everybody. And I should say that if you ask a question tonight, that entitles you to a piece of merch. And you can claim that at the end of this evening. Go back to the popcorn station, and you can claim your merch for asking a question. So let's get right on to our next speaker. He is a senior research data scientist at RTI International, specializing in AI, machine learning, and natural language processing to address challenges in public health, education, criminal justice, and addiction. He previously served as consulting services lead and machine learning engineer for Explosion AI. He partners with subject matter experts to explore how the intersection of data science and software development can create innovative solutions for complex problems. Let's welcome Peter Baumgartner.
All right. Hope you're ready to nerd out with me a little bit. I've got 200 slides of equations, and I got to get through them in like 7 minutes. So we're going to talk about evaluation. Click. Oh, lots of, okay, there we go. All right, so I'm just kidding. We're going to talk about 2 different questions today. The first question we're going to look at is, how do we know if an AI system works? I'm going to walk through 4 different methods we can use to answer this question. We're also going to talk about how we can use evaluation to help build AI systems. And I'm going to walk through 4 practices we can do to help us build AI systems. Now, when I talk about AI systems during this presentation, I'm generally going to mean anything that interacts with a large language model, but a lot of these principles and practices will apply to traditional machine learning as well. There we go. I get better at pointing. Let's talk about the first method that we can use. It's just vibes. So good news. If you've interacted with ChatGPT or a large language model, and you've looked at the response you get, and you can say, I like that, or that's not very good, congratulations. You're a junior machine learning engineer. You've just done a vibes-based evaluation. So vibes-based evaluations are really nice. They're a nice informal way to do an evaluation. You don't have to think about it too hard. You don't have to really outline what you're going to do. You're just going to do a basic sanity check. There are some downsides to just using vibes, right? Humans are subjective, we're not reliable, our opinions change day to day. It's really hard to track these things over time. Most importantly, it's really hard to scale this type of evaluation to a lot of examples so you can understand robustly how your system performs. So that brings us to our first practice, which I would call document your decisions. So even if you're doing just a vibes check, if you document what you input into a system, what you get out of that system, and any thoughts or observations or reflections on that, and you do that over a set of examples, what you're going to do there is build an evaluation data set. And that's going to be really useful to you as you build and evaluate an AI system. Start collecting these examples over time. All right, the second method for doing evaluation is something I called not wrong. So the idea here is that there are many more ways for an AI system to fail than there is to succeed, especially if you're building something that has a lot of component parts, tying them together. A failure at any point is very simple, very easy to encounter. So the idea with doing this not wrong method is take a look at your output and classify it as either wrong or not wrong. The nice thing here is that you can begin to aggregate these statistics over that evaluation data set that you're collecting and have an understanding of the failure rate of your system over time. There are still some downsides to this. It can still be subjective. You sort of lose some nuance. You might have a complex situation where the output's sort of partially right and it's unclear what to do with that. It also doesn't tell you like what makes a good answer. It's just focus on avoiding problems in your system. Luckily, we have a practice for that. So as you begin to review the output of your system, one practice you're going to want to do is characterize what correct is. So this can mean looking at attributes of good responses and good outputs, coming up with a checklist of those attributes, even developing a rubric with levels so you can understand what makes a good response. Once you do that, you're going to have something very useful for our next method of evaluation, which is using a large language model as a judge. So this is a practice that is currently going on in people evaluating AI systems. It's a little bit meta, but you can use a large language model to evaluate a large language model. It's actually very nice because it can evaluate complex tasks. You can quantify the quality of the output. And this is the first method that sort of scales to a bunch of examples if you want to do that. You don't have to do as much human review. Now, there are some downsides. It can cost a lot of money if you need to use a service for this. It requires you to get those clear task definitions and an idea of what a good response is and build a rubric or a checklist. And finally, there are a lot of ways in which large language models are biased and might give you, might influence your evaluation in a way that you might not find helpful. So as you build your AI system, you're going to come to a point where you're thinking, well, what should I work on? Like, what should I do next? I have a bunch of examples. And I would put forward that you should focus on areas where your system has trouble, the places where you're having errors. This might seem obvious, but a trap that you can fall into is focusing on the examples where you're trying to improve on something that's already good or successful, or you get a little bit of a perfectionist streak around making sure you have the best possible examples. I think it's much better and much more useful to raise the floor of the quality on your system rather than increase the peak of the system while you have a bunch of ways that system can still fail. All right, our last method is using formal metrics. So if you've been in data science or machine learning, you've probably used these before. These are things like F-scores or metrics like Rogue or Blue. These are really nice because you can associate a number with an output from a system. And what that means is you can track how that number goes up or down over time as you improve your system. So this is really great. It's well defined. There are some downsides. It can oversimplify this idea of performance. So not everything can just be distilled down to a single number. You also can get into what I would call metric tunnel vision. So where you're just focusing on make number go up instead of thinking about the larger system or context that you're building for. It's very easy to kind of lose the forest for the trees with this. All right, so the last practice here is make milestones from measures. So with everything but the vibes-based evaluation, you have something that you can aggregate and calculate over time. And I think it's the best practice when starting a project that's going to use AI to get to a point where you're able to evaluate the system end to end and build a baseline. And the goal in that project should be to iteratively improve on that baseline by making milestones out of how much you want to improve in your evaluation. So to review, we've covered 4 different methods we can use to understand if an AI system works. We've covered vibes, we've covered assessing whether things are wrong or not wrong, we've covered using a large language model as a judge, and we've covered formal metrics. And we have covered 4 practices you can use if the slide advances. There we go. To help you build AI systems, document your decisions, characterize what correct is, target your troubles, and make milestones from measures. Thank you.
Questions? Questions for Peter?
Hey, Peter, thanks for being here. I come at this from a software development standpoint where input X equals output Y, and we would write tests to verify that what goes in comes out the way we expect. Given the way AI works, and there can be so many different variations for the output, how does one go about testing what correct is, especially at scale?
Yeah, that's a great question, and I will also say as a data scientist, I've learned a lot from software developers about using testing to do this sort of thing. So it's definitely a challenge because you have, in some cases, non-deterministic output. You might get different things given the same input. It's hard to do that evaluation at scale. Some things I've seen are some evaluation metrics are sort of similarity based. So if you're looking at sort of like a gold standard output and the output you get from your system, the similarity between those two might change over time for any given test, but as you can set a threshold to say, like, well, as long as I run my test, I might get a different answer, but as long as this answer stays above that threshold, I'm going to count that as good. So that's something you can do. It's also an opportunity for a method called ensembling. So a lot of times, like, you would take multiple outputs from a model, aggregate them or combine them in some way, and a lot of times that can sort of like smooth out the variability you get between responses, and you can test against sort of like the ensemble output instead of any individual output.
Other questions for Peter? We'll go back here.
Thank you. So if we are using the model itself as a judge, when are we going to hit a point where we actually don't know if this is doing well or not? Because the model knows more than we do when it does the judgment. Yeah.
So that's a great question. Like, there's sort of a recursive evaluation problem, right? Where at some point you need to evaluate the evaluator, right? Yeah, there's a lot of interesting work here that's being done where people are sort of answering this question and they're understanding, like, what are the biases of large language models as evaluators, and how do we get them to do evaluation in a more consistent way. The sort of best practice right now is to simultaneously do like a large language model evaluation combined with a human evaluation and calculate agreement metrics between those two. That's sort of best practices, but there's always the question of, like, you do that on a sample set of data, but then, like, does that scale and does that agreement sort of apply to, or does it generalize to different examples? So yeah, ongoing research for sure.
We are going to move on for time. Thank you, Peter, so much. Great information. Okay, now for our third speaker. With a career background in science and engineering, he uses his experience to help others enter the STEM field. This led him to create STEM Plug. As a podcast host, TEDx speaker, and international author, he is passionate about sharing his knowledge of STEM and entrepreneurship, combining his technical expertise with innovative approaches. He wears many hats with pride: husband, brother, mentor, and a dedicated dog dad. He's known as Rich Novated. This is Rich Gilliam.
So I want you to imagine you're at a networking event, something like RTP180, and you're interacting with a lot of different people, different careers, different professionals. But what sets you apart? This was something that it was hard for me to figure out in my early career. And you know, I had to figure out what was my unique value proposition. So I want to ask you today, what sets you apart? What is your story? Today I'm going to talk about how you can use AI as your ally, strategies to amplify your personal brand. So what is personal branding, right? Personal branding is something that really effectively communicates what sets you apart from anybody else. So when we think of STEM Plug, right, I know you see my logo. It's 4 different colors, standing for science, technology, engineering, and math. And my unique value proposition is that I'm from the inner city of Philadelphia, I'm a black man, and I've been in STEM for the past 10 years. So I'm able to connect with a wide different communities. I've also done a TED Talk where I've been able to talk about transferable skills. And all of this is with me being in a career still as an engineer. So I want to ask you today again, what separates you from anybody else in this room? I want you to constantly think about that throughout this talk. And also going through consistent messaging. So here is a thumbnail you can kind of see on our podcast, the STEM Plug podcast, which you can check out on Spotify, Apple Podcasts, and Amazon Music, where we talk to different STEM professionals and really just share their story. But our messaging is consistent. So like I said, my branding journey in entrepreneurship started in 2022. And personal branding is a journey, right? So going from 2022, I started and launched my first book, right? So still, as I'm in my career, how can I start to scale everything that I'm doing? And I started to use AI. Really leveraging AI, different tools to see how I can start to really save time in my life, right? Because there's one thing that we don't have enough of, and that's time, right? So I want everybody to kind of read this quote. AI is a tool that can help you achieve more than you ever thought is possible. And that last 3 words is the key right there, if used right. So before we kind of go into the different tools that I would like to talk about that I've used within STEM Plug, just for branding and different things like that, it's very important that we have our foundation set, right? So as we look at how we define our unique value proposition, like I said again, what sets you apart from anybody else? Before you go into using different AI tools, think about these different things. Identify your target audience. Who are you looking to reach? I know for as me, within STEM Plug, I'm a lifetime learner. I love connecting with people that are lifetime learners as well as people that are interested in just learning about different areas of STEM. Next, now that we have our kind of target audience, we can kind of go into what AI tools we can kind of leverage. And then finally, going into how can we analyze and optimize the different research that we're doing. So now this is kind of going into an AI content pipeline. So there's a lot of AI tools that you can kind of use for personal branding, that you can use for content. And of course, I can't cover all that in a 7-minute talk. So I really just wanted to talk about some of the tools that I use. So Jasper is a very, unique tool that can really take the tone of the tone of how you speak, right? So a lot of times when we use AI, right, you might just enter in something and you're expecting, it comes back with something that you completely don't expect, right? So that's, again, why I say AI is a perfect assistant, not a servant. Spotify for podcasters is another platform that I kind of use that really goes into where I can post my podcast on multiple different avenues. And then we go into Pictory. Pictory is another cool AI tool where you can actually make like educational videos. So I don't know, by a show of hands, who here like goes on YouTube sometimes and really likes to look at different educational videos and stuff like that around like science or anything like that? All right, so you might like Pictory. And then finally, Hootsuite. Going into Hootsuite is an application where you can schedule your content. So whether you don't feel like posting to that on a certain day to a certain platform, you can use Hootsuite and really schedule out your content. And here is just a kind of direct example that I wanted to just kind of show you. So this is with Jasper, right? So I was able to implement my tone of voice, my tone of talk into this platform, and now this is able to give me different talks that I'm able to post on different platforms such as Facebook, LinkedIn, and Instagram. And here again is Hootsuite. So this is kind of just showing how we can schedule out our content on different platforms. So here you see, this is a full week of posting, right? So now you don't even have to worry about how you're going to post onto a certain platform. And finally, these are some of my favorite tools within AI. So a platform called Opus Clip, right? You're able to really put in a direct video, and it's able to give you short promotional videos. So this is promotional videos from our podcast. And then on the end, you can see from Pictory, this is a video that we were able to use around self-driving, as one of our speakers talked about earlier. So now you're able to kind of make some cool content. So finally, like I said, there are a lot of AI tools that I could have talked about that we use as far as within STEMplug or anything else with branding, but I couldn't cover everything. So I wanted to give you all this QR code, which will list some of the tools that I talked about, as well as it'll give you some other tools that you can find out and really help with your personal brand. So as we think about AI, right, AI can really enhance our personal brand, but it's important that we understand and have that foundational knowledge of what we're trying to do. So thank you.
Thank you. Questions for Rich? Go over here.
Rich, fantastic presentation. Really enjoyed it.
Thank you. Thank you.
And question for you on, so you have all this AI working for you to help your branding. Do you ever get in a situation where it comes up with something very unexpected and you're at first, whoa, 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 that's not me. What is that? And then you think about it and go, wow, no, that is me. That's right. It knows me better than I do. You ever get that feeling?
Yeah. Yeah, I mean that can definitely get scary, right? So like, especially like I said on the platform, Jasper, when you start to really intertwine and put in like different parameters that you're looking to kind of speak about, and then it really gives you those posts. It can be like a scary thing of like, wow, this is kind of all happening like that. So, but one thing I would say with AI, man, it's like you have to either embrace it or get lost, right? And like I said before, like one thing that we can't get enough of is time, right? And one thing that AI definitely does is definitely save time. When you're able to know how to maneuver it the right way, it can really help you scale and do a lot of different things that you're looking to do.
Other questions for Rich? We'll go over here.
Great presentation. How do you foresee AI helping Black businesses?
So definitely, with anything with AI, I feel like, we definitely need more data, and we need more, models that can definitely support our Black businesses more. But I will say one of the things that I see that AI can really do for black businesses is just really help get them out there more. You know, simple as that. You know, black businesses, I would say, are really thriving right now. And AI is a point of where, you know, black businesses can really not only just work with a wider community, but also, you know, improve themselves as well in different areas. So.
Thank you. You covered a lot of different tools on AI that do a lot of different things. So I'm curious, before you started using those tools, how were you approaching that work? How were you actually getting all of that stuff accomplished? And what was the moment that you felt like, oh, okay, AI is totally revolutionizing the way that I'm doing all of these tasks?
Wow, that's a great question. I would love for you to ask my wife, who's in the crowd, honestly. You know, like I said, AI, I got to the point where, like, working a 9 to 5, and I consider myself a STEMpreneur, so working a 9 to 5 and building a brand as well. So being at work during the day as an engineer, and then I'm working on different things, you know, within STEM Plug after work, and it was taking time away from my family, right? So then I started to see tools that can actually save me time, where now I can be at work and I can maybe schedule content to maybe post. So just really got into the part of where, like, it's really saving me time and also just allowing me to scale to a level that I couldn't do just on my own.
I'm going to ask a question, mix things up. What future trends should we anticipate, do you think, with all this?
So some future trends that I really see, and I guess that I'm excited about, is AI and, like, virtual reality. I think there's a lot that's going to be happening in that space. And I feel like I said before, I feel like we have to just get in an environment of just embracing everything that's happening and really learning these tools, right? So it's like you can either, you know, you can either get replaced by somebody that's learning AI, or you can learn it yourself. That's kind of how I look at it. So, yeah.
That's wise. Thank you so much, Rich.
Thank you.
Okay, we are on our final speaker, believe it or not. He is trained in synthetic biology and genomics, earning a PhD from UNC in the field of epigenetics. Currently, he leads the lab automation and bioinformatics teams at Locus Biosciences, an engineered bacteriophage company developing solutions for antibiotic-resistant bacteria and microbiome dysbiosis. Give it up for Dr. Taylor Penke.
All right, I'm excited to be a part of the event. I'm here to talk to you tonight about the silent pandemic, or the increasing rates of antibiotic resistance that are occurring in society today. So antibiotics have been some of the most effective and successful drugs in the history of pharmaceutical development. They've been around for almost 100 years, dating back to the discovery of penicillin in 1928. But over time, their efficacy is decreasing as antibiotic rates or antibiotic resistant rates increase. And we also know that antibiotics oftentimes kill your good bacteria as they're taking out the bad bacteria, the target pathogen that you're trying to eliminate in an infection, which really leads us to question the paradigm of how we're treating infections today in society. So at Locus, the company I work at, what we're working on is a platform to reach into the human body, eliminate the target pathogen very specifically while leaving the rest of the human microbiome or a patient's microbiome intact. And to do that, we're leveraging the bacteriophage, or the phage, which is the most abundant organism on Earth. It's all over this room, for example. And they're simply viruses that target bacteria very specifically. They work like many other types of viruses. They bind to the surface of a bacterium cell, inject their DNA, and then make more copies of themselves, eventually rupturing the host cell and killing the bacterium. So although they may look like something from Stranger Things, we think that these are possibly one of the most potentially positive tools that we could use for human health. but their specificity and the vast diversity that exists on Earth makes them really challenging to work with. So in this heat map that I'm showing on the left here, the x-axis is a number of different types of E. coli, different E. coli strains. And on the y-axis are a number of different phages. And the heat map is colored so that darker colors indicate better activity of a given phage. It's better at killing that bacteria. And there are two things that I hope you can appreciate from this graph. One is that phages have totally different patterns of activity of which types of bacteria they can kill, and also that you would need a combination or a cocktail of phages to be able to kill all of the E. coli strains on this particular map. And choosing that optimal combination of phages for your cocktail is one of the most challenging aspects of working with them. And so if I can take you back to middle school math for a second, the question that I always hated on tests was, you have 10 different colored balls, you put them all in a bag. How many different combinations of 3 colored balls can you pull out of that bag? Well, if you do that with phages, say you have 250 phages that you put in that bag, and you want to assess all potential 6 phage combinations that you can use, that's 100 billion different combinations that you would need to test or assess in some way. So these types of challenging problems really lend themselves to the intersection of automation and AI, which is why we're all here tonight. So we set out with a thesis that to build a good drug product, we would need to discover thousands of different bacteriophage and test them on thousands of different bacteria. And to do that, we decided to develop an automated platform that, for the purposes of this talk, I'm boiling down to 3 main capabilities. One is storage and retrieval. If you have thousands of different biospecimens, you need a way to access them in a traceable way and organize them effectively. And you also need some way to assess how good your phage or your phage cocktail is on all these bacteria, which involves mixing different liquids together and having some measurement device. And then finally, even the best of automation would struggle to test, at least in an efficient way, 100 billion different combinations. So we think that there's a strong role for leveraging AI to predict those right combinations of phages. So we set out to establish a storage and retrieval capability. We worked with a group called Hamilton Storage Technologies to develop these automated biobanks, which are essentially vending machines for biospecimens. We wanted to make getting 100 phage or 1,000 phage out as easy as getting a Coke for our scientists, or maybe even a little easier because these don't take your money and you don't have to take a dollar bill and rub it on the side of the instrument to get your particular sample. And so how these work are all your specimens are in these tiny little tubes that have barcodes on the bottom of them. They're these green capped items here. And this biobank has a robotic arm that can move these different racks into position and a tube picking device that allows you to select the right specimen that you want and organize them into an appropriate pattern for a scientist to use in their downstream application. And when you have all those organized, you can use this automated capper-decapper device to remove these caps, making it really easy to put these types of samples into downstream robotics. So with all of your samples in place, you need a way to actually mix the phage and bacteria and assess them. And to do this, we use a couple of work cells that are liquid handlers, which they're boiled down to their basic function. They're automated liquid movers. They have channels that can automatically aspirate and dispense liquids and move them together into these plates that have hundreds of different individual reaction containers. And many of them have robotic arms like ours here to move these plates into different measurement devices so that you can scale to a high throughput assessment of your phage. So essentially the question that we're trying to ask is which phage combinations have the best antibacterial efficacy on different strains? And we follow this simple workflow, which is essentially mix your phage and bacteria, allow the phage time to kill that bacteria, and then spot the remaining bacteria onto a media surface where they can grow into a colony, image that plate, and then simply count how many bacteria are left and how much has the phage been able to kill. So this video is an example of the automated imaging method that we use. This method scans barcodes on plates. And then in a second, you'll see a slow motion video of the arm placing a plate onto a light surface to take a quick picture. And what you get from this are images like the bottom here, where you have 96 different spots, and you can simply count those bacteria colonies that are present. And it's pretty easy to pick out which phages have been the best in those blank spots that are in the middle of the image. To do this at scale, we developed a computer vision algorithm that can automatically count all of those colonies and all those reactions. And we've used that to build a database of around 4 million different combinations of phage cocktails and bacteria interactions, which obviously large databases are great for leveraging AI. And we're in the beginnings of our story here with leveraging large language models, but we see a lot of promise in using this for our scientists to be able to access these databases and get recommendations from these models. So this example, the user is asking for a recommendation for a cocktail on a particular bacteria strain. This model accesses a database on the back end, gives a recommendation and also a rationale for why it decided to choose that. And like all large language models, you can interface it more directly and ask what are the phages that are present in that sample, so a scientist can then go into the lab and make that prediction or test that prediction. So while we're really excited about this platform and what we can use it for, we're even more excited to bring this into the clinic. And we're in the middle of a phase 2 trial right now for patients with recurrent urinary tract infections. So these are patients that are often have multi-drug resistant bacteria. They're coming back to the clinic for more antibiotics every 3 or 6 months. And so this particular drug targets E. coli. It's dosed through a catheter as well as IV. And in this trial, we're co-treating with a standard of care antibiotic. We've just completed part 1, which is unblinded, non-placebo controlled, a smaller patient set, but we're really excited about the results that we've been seeing. The middle panel is essentially measuring how much phage is present in urine, and as we expected, we have really high levels of phage present. And what we hope for and what we're really excited about is the dramatic reduction of bacterial burden, which is shown in the far right graph there. On average, we're seeing about a 1,000,000-fold reduction of E. coli levels in these patients. So we're really excited to take this into the placebo-controlled portion of the trial and look at statistical numbers to see how effective this drug product may be. So the thing that I want to leave you with today is hope for tools that we and others are building to turn what's been a burnt earth approach to treating infections for the last 100 years to something that's much more like a precision targeted strike. So happy to take any questions. Thank you.
Thank you. Dr. Penke, I'm over here to your right. Dr. Penke. I have a question right here.
Thank you for your presentation. I was wondering about how hard was it to implement these highly automated processes, and what were the struggles that you went through to succeed in implementation?
Yeah, lots of struggles. I'll say the ones that come to mind most are really effectively testing different quality control measures. So when you're working with tons of bacteria and phages are known to, they don't actually jump, but that's the joke, that they get all over all of your samples or into neighboring wells. And so the types of quality controls and the different types of labware testing that we needed to put in place to be able to make sure that contamination wasn't occurring into neighboring wells and make sure that the results were essentially reliable was one big challenge. And then also just setting up these types of automated systems. There's so many different things that can go wrong. The more complex you build your system, the more things that can go wrong. And so over time, just continually optimizing to reduce those errors, the frequency of them, and then putting in automated checks to recover from those errors that are most common. Those are a couple of the biggest struggles that we dealt with.
Other questions? Go right here.
Thank you. How long did it take? How much did it cost?
Excellent questions. So we've been at this as a company for 9 years. We've been developing our automation for 5 years. We actually acquired a company from San Francisco that had the initial liquid handler that was our gateway robot into the space. Ultimately, between labor and capital equipment, we've invested probably $2 to $3 million into these particular systems. And yeah, did that answer your question? What was the last one? $2 to $3 million.
We'll go right here.
Hi, thank you so much for your presentation. You did a great job making something very complicated, really widely applicable, so thank you for doing that well. I just had a question about your concerns about the ability to scale this to the general population, like thinking about all the constraints post-studies.
Yeah, so it might be helpful to say there are a couple of different approaches to phage therapy. One is a very personalized approach where you actually get the bacteria sample from the patient, and then you look at your bank and take your best set of phages directly on that sample. Then you manufacture that and you take that back to the patient and treat them. And that's how a lot of phage therapy is done. A lot of the emergency INDs that have been done and have been successful have been that way. We decided to take a different approach, which was to invest in a lot of this upfront to be able to get what we refer to as a fixed phage cocktail, which is something that we could give to many, many patients. So we have the manufacturing capability to be able to scale this to commercial to treat patients throughout the United States. The particular product that I mentioned is for E. coli in urinary tract infections. So that is maybe a different level of scale than all types of infections and all types of bacteria. But we're also working on other types of bacteria as well as other indications to kind of spread out from our initial lead product.
Okay, and for the final question of the night, we'll go over here.
So this is a biology question. Can phage therapy actually clear an infection, or is it kind of like biocontrol of invasive whatever, where you just keep the level down to the point where you're no longer symptomatic?
Yeah, wonderful question, and the short answer is we don't know quite yet. But I think that there are a couple of options, both of which are positive for patients. One is what you mentioned, where you keep it to a level that's asymptomatic for the patient. We obviously would like to get to a point, particularly for urinary tract infections, where you can completely clear that. In our initial study that was non-placebo controlled, most of the patients had undetectable levels of E. coli out to 34 days, so they could come up after that. We don't know for sure. The other option is that phage can also make bacteria resusceptible to antibiotics that they were not previously susceptible to, and they also can bind to virulence factors or other ways that bacteria use to affect human cells that they can adhere to or invade to human cells. There are phages that target the mechanisms, essentially, that the bacteria uses to do that. So you could imagine a scenario where you push evolutionarily a bacteria to become what was once a pathogen to something that's a commensal that can live in harmony.
Thank you, Dr. Penke, everybody.
Thank you.
All right, did you enjoy RTP180 tonight? Nice. Thanks for being here. Once again, we want to thank RTI International and District Station, a Zaremba management company, for being our sponsors. Let's hear it for our speakers one more time. Great information. I want to remind you that we are now a quarterly event. Our next RTP 180 is going to be on August 15th. The topic is color. It should be very vibrant, to say the least. We hope to see you there. You can register for that in the coming weeks by going to rtp.org. I want to thank you again for joining us. We're going to open the bar back up in 1 minute. Our speakers will be around if you want to ask them a question, and we hope to see you in August. Thanks, everybody. Good night.